All right, welcome to The Explainer. Today we're diving into this really wild new battery design that promises to be more powerful, cheaper, and safer. And get this, its secret is that it actually starts with a key part, missing.
Okay, let's get right into it. You know, we're all on this global quest for better energy storage, for our phones, our cars, our entire power grid. But what if the answer isn't about adding more stuff, but actually starting with less? Now, I know that sounds completely backward, right? But trust me, it's a truly brilliant piece of engineering.
So what is this thing? This seemingly incomplete battery? Well, it's a design that could totally change the game for energy storage, thanks to its incredibly high energy density and a much simpler, cheaper manufacturing process. Here's the key takeaway. It literally builds its own anode, the part that holds on to all those energy-carrying ions when you charge it up, on demand. It's not built in the factory. It makes it itself, right inside the battery the very first time you use it. Okay, and this slide just shows it perfectly. On the left, you see how it starts out. Pretty simple, right? A cathode, electrolyte, and a current collector. But then you hit it with that first charge, and bam, a brand new metal anode just appears. It's exactly like starting with an empty plot of land and only pouring the foundation right when you're ready to start building. But like any hero in a story, this one has an Achilles heel. This elegant, minimalist design has a critical flaw that causes it to fail much, much faster than the batteries we're all used to.
And the root of the problem is something called poor reversibility. It's like with every single charge and discharge, little pieces of that self-made anode just break off and get lost forever. Think of that foundation we just talked about. Now imagine it crumbling away a little each day, leaving behind this useless rubble that scientists actually call dead metal.
And this diagram really shows you the chaos that's happening on a microscopic level. You can see the plating's all uneven, you've got these chunks of dead anode literally breaking off and floating away, plus all these destructive side reactions happening with the electrolyte. I mean, it's a tiny war zone in there, and the battery is losing.
This just lays it all out, plain and simple. It's the problem versus the goal. On the left, that's what you get with uncontrolled plating, a corroded, messy, inefficient disaster. But on the right, that's the dream, a perfectly smooth, uniform, super efficient metal surface. The difference you're seeing here? It's the difference between a battery that dies after a few cycles and one that could last for years.
So, okay, the problem is clear. How in the world do you fix this crumbling foundation? Well, scientists are getting creative. They're basically attacking this from two totally different but equally brilliant angles.
Think of it like this. You've got strategy A, we'll call it the perfectionist approach. This is all about making every single cycle absolutely flawless. Then you've got strategy B, the pragmatist. This one accepts that, hey, maybe perfection is impossible, so let's build in a clever backup plan. Let's dig into the perfectionist strategy first.
All right, so the perfectionist approach. This is all about making that metal plating process as clean and perfect as possible every single time. And where do you start? You start at the very bottom, with the current collector. That's the surface where the anode gets built. So tactic number one is to actually engineer that current collector. Remember our empty plot of land? The goal is to make it, well, stickier for the metal atoms. They do this by creating these special surfaces they call sodiophilic, which is just a fancy way of saying sodium-loving, or potassiophilic for potassium. This basically guides the atoms to land smoothly and evenly. It's almost like they've created an atomic-level Velcro, making sure everything sticks just right, preventing all those lumps and bumps.
And look at this. The proof is right here in the pictures. On the left, that's your standard copper surface. You see how the potassium plate's on there? It's a rough, lumpy, inefficient mess. But on the right, on that engineered surface, would you look at that? It's a perfectly smooth, dense layer. It just goes to show if you prepare the surface correctly, you get a perfect foundation every single time.
Okay, so that's the surface. But the other part of this perfectionist strategy is to control the environment around the anode. Specifically, we're talking about that liquid inside the battery, the electrolyte. Think of it like a highway for ions, and it turns out it has a huge impact on the anode's health.
What scientists can do is encourage the battery to form the super important protective film called the solid electrolyte interface. You'll see it called the SEI. The best way to think of the SEI is like a microscopic suit of armor, or maybe a really smart bodyguard for that new, fragile anode. It keeps the bad stuff out, but lets the good stuff, the metal ions, pass right through.
And this illustration is just fantastic. It really shows you how complex this tiny suit of armor actually is. It's not just some simple film. It's this intricate, multi-layered shield that protects the anode from all the corrosive stuff in the electrolyte. This is some seriously impressive engineering, happening at a scale you can't even see.
Okay, so that's the perfectionist strategy. But now, let's check out the other path, the pragmatist's approach. This one asks a different question. What if instead of aiming for perfection, we just plan for a little bit of failure?
Honestly, this idea is so clever. The whole concept is to build a backup supply, a metal reservoir, right into the battery from the get-go. This is like having a little stash of extra concrete on site at our construction project. Every time a tiny crack appears in the foundation, you've got the materials right there to patch it up. It could extend the battery's life dramatically.
So how does this work in practice? Well, it's pretty ingenious. They start by creating a special cathode that's loaded with extra metal. Then, during that very first charge, the cathode doesn't just release the ions it needs, it releases extra metal ions. These surplus ions go over and form a little reserve pile on the anode. Just waiting. They're ready to compensate for any material that gets lost in the future. The really critical thing here is that this internal repair kit is built right into the battery's chemistry from day one.
So there you have it. You've got these two powerful strategies working together. On one hand, you have the perfectionist approach, engineering for flawless cycles. And on the other, you have the pragmatist approach, building in a backup plan. With these tools, the anode-free battery is going from a cool idea with a fatal flaw to a real, serious contender for the future of energy storage.
And the potential here, it's just massive. I mean, listen to what the researchers themselves are saying. This is a promising solution for batteries that are not only more powerful, but also safer and way easier to build. We're talking about an impact on everything from the phone in your pocket to the entire electric vehicle industry.
So what's the big takeaway here? It's that the science on this is moving at an incredible pace. This revolutionary something-from-nothing technology is getting closer and closer to being in our everyday lives. At this point, the question really isn't if these anode-free batteries are going to change the world, it's just a matter of when.